Hi and welcome to Cherry Pie Math. This video is going to introduce the distributive property and show how to use it in really simple two-step equations. So to start, I have two equations here. I have 4x plus 6 and then I have 2 times 2x plus 3. And I'm going to be illustrating them with triangles for the x's and with squares for ones, I guess. So pause the video and see if you can illustrate the 4x plus 6 and then 2 times 2x plus 3. Okay, so if you want to look at it now, I'm going to go through it. If you didn't write it down, I forgive you. It's okay. So 4x plus 6, that means I have 4 x's, so I'm going to do 4 triangles here. And then I have 6 squares, because I have 6 ones, I guess, because that's my constant. Okay, so that's how I would illustrate 4x plus 6. Now let's look at this next one. Remember that when you multiply something, it means, like if I do 2 times something, it means that I'm doing that something twice. So 2x plus 3 would look like this. I have 2 triangles and I have 3 squares. And I'm going to be doing that twice because it says times 2. So if you look at it, even though it's in a different order, they both actually have the same amount of triangles and they both have the same amount of squares put all together, even though it's written totally differently. And this is where the distributive property comes in. It basically is going to say that if there's a number in front where you're multiplying it, everything in it gets multiplied by that same thing, as you can see here. So here I had 2 times it. So 2x was multiplied by 2 and 3 was multiplied by 2. And that's really the distributive property at its core. So if I was to write it out, the distributive property would look like this. So if I have A times, actually I'm going to make it B plus C. This is the same as saying A times B plus A times C. So one way I would see students look at this is they would say, okay, I would do A times B and A times C. But this is all it is you would do this number times this number, and then you do this number times this number. So if I was to write it out, and usually this middle part, we actually don't have to write it down. So this is just for illustration. You don't have to know how to, you don't have to write out the middle part. What really matters is this column over here. And you'll see what I mean in a second. So this first one, you would do 3 times 4x. And then you do have to keep that sign in the middle, so it would be minus. And then I would have 3 times 8, which would become 12x minus 24, for example. Or in this one, again, we have to be careful about any negatives. So I would have negative 2 times 10x. And then I would have negative 2 times positive 5. Remember that a negative times a positive is still a negative. So it would be minus 2 times 5 again. This would be negative 20x minus 10. And this last one, if there's no number, we assume that there's a 1 there. And in this case, it's negative 1 because there's a negative in front of the x. So I would have 8 times negative x, and then 8 times plus 8 times 6 because both of these are positive. And that would become negative 8x plus 48. So take a minute and just kind of see. I'll go ahead and highlight these. Let me see if I can make that bigger. So these came out to be like that. So you can see that the second term kind of stays the same. The first term kind of it stays in the same place. You just have to be careful about those negatives. Remember, a negative times a negative is a positive, and a positive times a negative in either order will become a negative. So the reason distributive property works, like I said before, is because we multiply the parentheses over and over, including everything inside. So for example, And we kind of saw this with the triangles and squares. But if I have 3 times 4 minus 8, this is really saying 4x minus 8 plus 4x minus 8 plus 4x minus 8. And then what we call it combining like terms. Anything that has the same variable and the same exponent, you would combine together. And you end up seeing that, oh, that's there 3 times, and that would be 12x minus 24. And so that's why the distributive property works, is you're basically putting all of those parentheses together. Like if you spread it out, you would combine all those different parts of the parentheses together. So when using the distributive property, please keep track of the signs. So remember, a negative times a negative is a positive, and a positive times a negative in either order is a negative. And then obviously a positive times a positive is a positive. So sometimes we see these in two-step equations. There's actually more than one way to do this, but the most common way that I'll see the distributive property being used is I'll first distribute the number. So it really becomes a 3-step equation because you have to take care of this number on the outside. So you would do like this one would be 3 times 5x would be 15x. And then 3 times negative 2 would be minus 6. And then it's still equal to 54, and then you would solve it. So like I'd add 6 to both sides. And I have 15x because these canceled out. And this becomes 60. And then I would divide by 15. So x is equal to 4 in this case. So all you have to really do is just first distribute it, like I said. I'll make that in black so you can see it better. So I'll do it again. In this one I have a negative. Negative 2 times 4a would be negative 8a. Negative 2 times negative 10 is positive 20. And then I just copy down whatever the constant is on the other side. And then I solve it like a normal two-step equation. I'd subtract 20 from both sides. So I have negative 8a equals 24. And then I would divide by negative 8. So a is equal to negative 3. So this is what I normally do. Because I just like getting rid of the parentheses as soon as I can. It's actually not the only way though. There is another way to get rid of the parentheses, I guess, right away. And this is a little bit weirder because we're basically doing SADMEP twice. So just a reminder, SADMEP is PEMDAS in reverse, and this is how you solve, right? So we start with subtraction, addition, and we work our way up to parentheses. The problem is here, this is all parentheses, so yes, even though there's subtraction, because it's inside the parentheses, we would do it later. So what we would do is first we would divide by what number is on the outside, so in this case 3. And that actually gets rid of that, so I have 5x minus 2, and then I just have to remember to do that to the other side, and then I would solve it. So I would add 2, 5x equals 20. Divide by 5, x equals 4. So you get the same answer, you're just doing it in a different way. Like here, so you would divide by negative 2 first. And it's okay because all you have is the parentheses and the number in front of the parentheses. So that cancels out. You have 4a minus 10 equals 22. And then you would solve it. So you add 10 to both sides. And that would be 32. Sorry, this would be negative 22. That's why I was like, what? That doesn't make any sense. So see, be careful of those negatives. If I hadn't remembered to put that negative there, because 44 divided by negative 2 would be negative 22, that would mess up my answer. So there we go. So when I add 10 to both sides, that actually becomes negative 12, and then I would get a, ran out of space, a equals negative 3. And one way to check, in case you're not sure, is always to just plug in this number back in here. So if I did negative 2 and then 4 times 3 minus 10, this would be negative 2 times 12 minus 10. Negative 3. Oh my goodness. These negatives are going to kill me. That would be negative 22. That would be positive 44, which checks out. That is the number on the other side. So if you're not sure, just double check. Make sure you plug it in. And please, please, for the love, watch those negatives. Even I was getting messed up on the negatives, and I'm making this video for you. So please make sure you watch out for those negatives. So either way you did it, which one you liked better, it really doesn't matter. So think about which one you liked better, and why. I like this way better, because honestly, I get messed up with negatives less. This one, because there's more division, it kind of messes up my brain in terms of negatives. But either way is fine. If you want to distribute first, or if you want to get rid of that number first, it's totally fine. So some things to remember: keep those positive and negative signs in mind, please. Another thing is everything gets multiplied by the number on the outside. A common mistake I'll see is students will see this, for example, and they'll only remember to do this. So they'll have 3x plus 4, but really it should be 3x plus 12, because you would multiply that 3 into everything. And then to solve for x, you need to get rid of parentheses. Notice in both of these methods, I wasn't able to start really canceling stuff out until I got rid of the parentheses. So that is always your first step whenever you're solving, is get